we have an imaginary situation here where you want to program a robot to hand a person a drink. So one important thing it has to distinguish is whether any movement that's detected by its visual sensors, which in this case its visual sensors would be analogous to a human, the human eyes, is the result of the movement of its sensors or because a person is walking past, and that's creating the movement. And so it's the same dilemma that we have with corollary discharge theory. This thing is moving across my retina. Is it because my eyes are moving and the object is still, or is it because the object really is moving? So how do we figure that out? And so I want you to use corollary discharge theory to help the robot interpret the data from the following two situations. So there's two situations there that, below. But first, let's go over corollary discharge theory. And so let's see, we'll use green's a good color. So the idea of corollary discharge theory, which by the way, I hate the term, it's kind of descriptive, but the phrasing is so weird. So corollary discharge theory refers to sort of a secondary message sent from the eye muscles to the brain, telling the brain that, hey, the eyes are being told to move. So that's what the corollary discharge is, that there's this second message, this second little bit of information that goes to the brain. So if I'm following this object with my eyes, my brain is telling my eyes to move along, right? My motor cortex is sending the signal to my eyes, telling my eyes to move. But there's a secondary message that goes to other parts of the brain involved in movement perception, where it tells those parts of the brain, hey, by the way, the eyes are moving right now. And that's the corollary discharge. And so the brain has two pieces of information that it needs to evaluate, or basically two types of questions it needs to ask. It needs to find out, number one, did the eyes, or in the case of our robot example, the visual sensors, move? Was there a corollary discharge saying that, hey, the eyes moved? And then the other piece of information that is needed is right here, and that is, did the object's image change location on the retina? And in general, we have a basic rule that we can use. If the answer to both are yes or, oops, no, so if answers to both questions are basically the same, both yes or both no, then there will not be movement perceived. You'll perceive a still object. And so a simple example of that would be, I'm staring at the pen, my eyes are not moving, the pen is not moving. Two no's, a still object. The other possibility could be that the pen is not moving, but my eyes are moving left and right. So if my eyes are moving, but the pen is not, let's think of what that's going to do. Are my eyes moving? Yes, my eyes are being told to move. Does the image of the pen move along my retina? It actually does, because my retina is getting a different image as my eyes move. And so the relative location of this pen on the retina is going to change. And so if I'm just moving my eyes while I look at a still object, I'm going to get two yeses. And so in both those cases, no movement will be perceived. And so we have these two situations. You stare at a fixed object, which gives us no and no, or we move our eyes past a fixed object, in which case we get a yes and a yes. Yes, our eyes are moving. Yes, the image changes position on the retina. And so in both these cases, we are going to not have movement perception. I guess we can say 2 rules. So this is rule number 1. Or maybe I should not use 1 because I don't want to be confusing. So rule A, how's that? And then rule B, which I'll just do over here, is if the answer is some combination of yes and no, right? So it could be yes, no, or no, right, no, yes, right? So as long as one is yes, one is no, then movement gets perceived. And so once again with my pen example, if now instead of my eyes moving, the pen is what moves. So I'm going to look straight at my camera and in that case, are my eyes moving? No. But is the image of the pen moving along my retina? It sure is, right? And so when we have one no and one yes, yes, we perceive movement.